Hey everyone, welcome to Math 104. We're working on section 6.3 today, complex fractions. Complex fractions are fractions within fractions. So you've got a larger fraction, and in the numerator and denominator, there are smaller fractions. So we've got two main methods for simplifying these. Okay, here's an example of a complex fraction. All right, here's your main division bar. So here's the numerator, and here's the denominator. The numerator is a small fraction, and the denominator is a small fraction. Now the first method, what we want to do is simplify both the numerator and denominator down into single fractions. Well, we already have that. So we're pre-simplified. Now we can go right on to step 2, which is converting this division into multiplication the way we've done many times in the past. All right, so when we do that, the first fraction stays exactly the same. So we get x plus 1 over 2x, and we're going to multiply by the reciprocal of the bottom fraction. Remember, the reciprocal we get by flipping it over. So that's 4x over 3x minus 1. All right, now all we have to do is cancel and then multiply. So we've got an x on top, x on the bottom, so we'll cancel those. 4 over 2 reduces to 2 over 1. And that's it. So on the top, we've got 2 times x plus 1 over 3x minus 1. And if you like, you can go ahead and distribute, but not necessary. Your turn number 1. All right, so we've got simplified fractions in the numerator and denominator, so we'll go directly to step 2. 1 minus x over 4x. Convert to multiplication, that gives us 8x over 1 plus x. All right, x's cancel. 8 over 4 is 2 over 1, so that gives us 2 times 1 minus x over 1 plus x, or 2 minus 2x over 1 plus x. So either form of those is fine. All right, next example, we're going to have a few more variables than this one. All right, so again, we're down to a single fraction on top and the bottom to start, so we can go right to step 2. So that gives us 4x to the fourth, y squared over 9, times the reciprocal here, which is 15 over 12 x squared y to the fifth. All right, now let's see what we can cancel. We got 4 and 12 here, so that reduces to 1/3. We got 2 x's here and 4 of them up here, so we'll have 2 remaining up here. So I'll circle that so I remember. And then 2 y's here and 5 of them down here, so we'll cancel 5 of them with 3 remaining there. And now we've got this fraction here, 9/15, that reduces to, or 15/9, that reduces to 5/3. So on top, what we have left is, we got a 1 times x squared and a 5. So that's 5x squared on top. And on the bottom, we have 3 times 3. That's going to be 9 for the coefficient. And the remaining variables are y to the third power. So 5x squared over 9y to the third. And that brings us to your turn number 2. All right, so we'll convert this to multiplication. Flip that second fraction over. Now we've got 16 over 8. We can reduce that to 2 over 1. We've got 3 over 9. That reduces to 1 over 3. And 3x's on top, 4 on the bottom. We'll cancel all but 1x on the bottom. And same thing with the y's. So what do we have left? We got 2 on top. We got 3 on the bottom. And we have xy. So 2 over 3xy. All right, so in all the ones we've seen so far, we've been already down to a single fraction on top and the bottom. That's not always going to be the case. Our next example, we do not have a single fraction on top and bottom. So we're going to have to turn these into single fractions. So that means combining these by finding a common denominator. So the denominator is x, so we're going to have to write 1 with the denominator of x. So what's that? Well, it's x over x, because anything divided by itself is 1. So we get 2 over x minus x over x. And here 2 over x plus x over x. All right, now we can combine them. So the top turns into 2 minus x over x, and the bottom turns into 2 plus x over x. All right, so there's step 1. We've succeeded in creating a single fraction on the top and a single fraction on the bottom. Now we'll convert to multiplication. So that's 2 minus x over x times the reciprocal x over 2 plus x. The x's cancel, leaving 2 minus x over 2 plus x. Your turn, number 3. So we need a common denominator of x. So we're going to multiply 6 by x over x, and that gives us 6x over x plus 1 over x. Now we'll do the same thing with 7 here, giving us 7x over x minus 3 over x. Now we can combine 6x plus 1 over x, and the bottom is 7x minus 3 over x. Convert to multiplication. Now that we have a single fraction on the bottom and top, now we can convert to multiplication. Don't do it until we have a single fraction on both the numerator and denominator. Right, convert to multiplication, x's cancel, and we got 6x plus 1 over 7x minus 3. Now in the second method, we are going to take a look at all the little fractions and then find the least common denominator for all of those little fractions in both the numerator and denominator. Then once we have that LCD, we're going to multiply both the numerator and denominator by the LCD, and that will have the effect of removing all of those little fractions. All right, so I'm going to revisit the last problem. We're going to use method 2 on this one. So let's take a look at the little fractions. We have 2 over x and 2 over x. Well, the LCD is clearly just going to be x. So we'll multiply by x over x. And when we do that, we're going to have to distribute the x into 2x minus 1. Alright, x times 2 over x is 2x over x. And x times 1 is just x. So that's what we get on top, and on the bottom we've got 2x over x plus x. Alright, now we can do some simplifying. These x's are going to cancel, so it gives us 2 minus x, and these x's cancel, giving us 2 plus x. So, 2 steps and we're done. Clearly in this case, method 2 is much easier. Your turn, number 4. Alright. Looking at the little fractions, x is in the denominator, so our LCD is x. So multiply the top and bottom by x over x. X times 6, that's 6x, plus x times 1 over x is x over x. And here, distribute in, we get 7x minus 3x over x. Now we can simplify, giving us 6x plus 1 and 7x minus 3. Now in this example, our two denominators for the little fractions are both binomials. If we try to multiply this by the LCD, we're going to have to multiply by x plus 2 times x minus 1 in both the numerator and the denominator. And that's going to be a big mess. That's going to take a long time. So we don't want to do that. So for a problem like this, where we're going to have a fairly complex LCD, let's go back to method 1. So here, we want to combine these into a single fraction, so we need a common denominator. Here the denominator is x plus 2, so we need to change 1 to have a denominator of x plus 2. Well, anything divided by itself is 1, so this will be x plus 2 over x plus 2. Same thing down here, except we have x minus 1 as the denominator, so we're going to rewrite 1 as x minus 1 over x minus 1. All right, now we'll combine. So we got x plus 2 plus 3, that is x plus 5, over x plus 2. And the bottom, we have x minus 1 plus 6, so that is x plus 5, over x minus 1. All right, now we're down to a single fraction on the top and a single fraction on the bottom. So now we can convert to multiplication. X plus 5 over x plus 2 times the reciprocal. So that gives us x minus 1 over x plus 5. Now we've got matching binomials on the top and the bottom. X plus 5's cancel. X minus 1 over x plus 2. Your turn, number 5. So on top, we need a common denominator of x minus 4. So we'll write 1 as x minus 4 over x minus 4. And here we'll write this one as x plus 1 over x plus 1. Combining, here we have x minus 4 minus 1, which is x minus 5, over x minus 4. And here we've got x plus 1 minus 6, which is x minus 5 over x plus 1. Now we'll convert to multiplication. Now we can cancel the x minus 5s, leaving x plus 1 over x minus 4. Now, next example, we're going to choose between our two methods. 4 over y minus 4 over x over 4 over y plus 4 over x. Now, in the numerators, we have all monomials. And often, it's going to be a lot easier to use method 2 if we have relatively simple denominators. So let's find the LCD of the denominators. All right, in all of these denominators of little fractions, two variables we have are x and y. They're all to the first power, so that means our LCD is xy. So we're going to multiply both the numerator and denominator by xy. Now we'll distribute xy into these. So we get 4xy here and 4xy here. We do the same thing here. So remember, when you're multiplying something by a fraction, you multiply by the numerator only. If you forget, just write this as xy over 1. So we multiply straight across. All right, now we can do some cancellations here. Now we've got some matching variables. So here we have matching y's. So that turns into 4x minus, here we have matching x's. We'll cancel the x's, leaving 4y. And the bottom, the y's cancel, leaving 4x. And then the x's cancel, leaving 4y. All right, now we can do some factoring. We can factor out a 4 on top and a 4 on the bottom. The 4's cancel, leaving x minus y over x plus y. Your turn, number 6. So just like with the last example, if we look at the denominators, we have x's and y's, all the first power, so our LCD is x times y. So multiply by xy over xy and distribute in. So it gives us 3xy over x plus 3xy over y over 3xy over x minus 3xy over y. Now we can do some canceling. X's here, leaving 3y. Y's cancel here, leaving 3x. X's cancel here, leaving 3y minus y's cancel here, leaving 3x. Now we can factor out the 3's to get y plus x and y minus x. 3's cancel. And we get y plus x over y minus x. Next up, as always, gotta be prepared to do some factoring. All right, we are down to a single fraction on top of the bottom. We're going to go directly to converting to multiplication. Here we have difference of squares, so this will factor into x plus 4, x minus 4. We got 6 over x minus 4 times x plus 4, x minus 4 over 12. Now we can do some canceling. We had x minus 4, those cancel. 6 over 12 reduces to 1/2. And what remains is x plus 4 on top and 2 on the bottom. X plus 4 over 2. Your turn, number 7. We'll convert to multiplication. Now again, we have difference of squares up here. So factoring gives us x plus 7, x minus 7 over 24. And now we can do some canceling. We got matching x plus 7s, those will cancel. 8 over 24 reduces to 1/3. And so that gives us x minus 7 over 3. Now sometimes things look a little bit more complex than they actually are. So this thing looks like a big mess. But let's just take a look at the little fractions and the denominators of those little fractions. So we have a 3, a 9, and a 3y. So if we want to find the least common denominator, we'll just notice that 9 is a multiple of 3. So that means the LCD will have 9 as a coefficient. And we only have one variable, y, so our LCD is just 9y. So if we want to multiply these, oops, let me get rid of that. Well, if we want to multiply by 9y over 9y, it's going to remove a lot of this complexity. All right, now we'll distribute in. 9y times y is 9y squared. And here, we're going to do 9y times y minus 3 over 3. And we'll do some canceling there, simplify that. Now over here, we're going to do 4 times 9y over 9. And here we got 2 times 9y over 3y. And now we can cancel. So 9 over 3, these will go away, leaving just a 3 here. And then we can distribute 3y into here. And when we distribute, 3y times y is maybe we're doing too much at once here. I'm going to do this in 2 steps. Okay, so I'm going to write this as 3y times y minus 3. So what I did here is reduce 9 over 3 to 3 over 1. And so we got 3y times y minus 3. So fractions are gone up top. And then here the 9's cancel, leaving 4y. And over here, 9 divided by, the y's cancel. 9 divided by 3 is 3, times 2 is 6. So just like that, all the fractions disappear. Now we can simplify. 9y squared, and I'm going to distribute negative 3y into here, so that's negative 3y squared. And negative 3y times negative 3 is positive 9y. In the bottom, we just have 4y plus 6. All right, let's consolidate here. 9y squared minus 3y squared is 6y squared. Now let's factor and see if we can simplify it all. So I'm going to pull out a 3y, get 2y plus 3, and here I can factor out a 2, and get 2y plus 3. So now we have matching binomials. So those will cancel, leaving just 3y over 2. Your turn, number 8. All right, let's look at our denominators here. We got 4, 4, and 2x. So that makes the LCD 4x. Now I'm going to distribute 4x up top. 4x times x is 4x squared. And multiply by x plus 2, so 4x times x plus 2 over 4. And on the bottom, we go 3 times 4x over 4 minus 5 times 4x over 2x. Now let's simplify. All right, nothing we can do here. Here we'll cancel the 4's, leaving x times x plus 2. And here we'll cancel the 4's, leaving 3x. And here we can cancel the x's, and 4 over 2 reduces to 2 over 1. So minus 10 there. Now distribute negative x into x plus 2, so that is minus x squared minus 2x over 3x minus 10. Now we can combine here. So we got 3x squared minus 2x over 3x minus 10. Now we could factor out an x up top, but that gives us 3x minus 2. And nothing we can cancel there, so we might as well just leave it as 3x squared minus 2x over 3x minus 10. Now the next one is a really crazy looking form that we can turn into just a standard quadratic with just one operation. Alright, so we've got all these little fractions. Let's take a look at the denominators. We have a single variable x, and the highest exponent is 2. That makes the least common denominator x squared. So what we're going to do is multiply by x squared over x squared. And now we take this x squared and distribute into each of these. Now something interesting happens when we do that. X squared times 1, that just gives us x squared. When we take x squared and multiply it here, we get 2x squared on top over x. And here, when we distribute here, we get 8x squared over x squared. Now do the same thing on the bottom to produce x squared plus 3x squared over x minus 10x squared over x squared. And now look what happens when we start canceling. 1x cancels here, leaving the middle linear term. And over here, the x squareds cancel, leaving the constant term. And now we have a standard quadratic. On the bottom, we do the same thing. X squared plus 3x. X squareds cancel, minus 10. Now we have two factorable quadratics. We can factor and cancel. Up top, you need two numbers to multiply to get negative 8, add to get 2. That's going to be plus 4 minus 2. And on the bottom, you need two numbers to multiply to get negative 10, add to get 3. So that is x plus 5 times x minus 2. So we got matching x minus 2s, those cancel. And our answer is x plus 4 over x plus 5. Your turn, number 9. Alright, so same deal. The LCD is x squared, so we're going to multiply by x squared over x squared and distribute. That gives us x squared minus 3x squared over x minus 10x squared over x squared. And on the bottom, x squared plus 11x squared over x plus 18x squared over x squared. Alright, now we can cancel. So we get x squared, 1x cancels here, leaving behind 3x. X squareds cancel here, and we have 10. And on the bottom, we have x squared plus 11x plus 18. That gives us two factorable quadratics. So these will factor into we got x minus 5, x plus 2 on top. And x plus 9, x plus 2 on the bottom. The x plus 2's cancel. And we have x minus 5 over x plus 9. Now this technique is really useful for removing negative exponents. So next example. X to the negative 2 plus y to the negative 1 over x to the negative 1 minus 5y to the negative 3. So just like we can remove all the fractions at once, here we can remove all the negative exponents at once. Take one operation to do it. So what we need to do is take a look at all of the exponents on the same base. So here are the x's. We've got negative 2 and negative 1. You take the larger negative, negative 2, and turn it positive. So we want x squared. So we're going to multiply by x squared over x squared. And then do the same thing for the y's. We have negative 1 and negative 3. Negative 3, this is a larger negative. Turn it positive and put it over here. So we're multiplying by x squared y to the third. Now we'll distribute it. So what do we get? We get x to the negative 2, x to the 2, y to the 3, plus x squared, y to the third, y to the negative 1. And on the bottom, x to the negative 1, x squared, y to the third, minus 5 times, I'll write this as x squared, y to the third, y to the negative 3. All right, so now what do we get when we multiply x to the negative 2 times x squared? Remember properties of exponents? We add the exponents. Negative 2 plus 2 is 0. So we get x to the 0 power. Recall anything to the 0 power is 1. So these two things cancel each other out. Same thing with y to the third times y to the negative 3. Those cancel. Now we just apply the properties of exponents to everything else. All right, these cancel, leaving y to the third here. Plus, over here, we have 1x. So that is remains x squared. Now we add these two exponents together. 3 plus negative 1 is 2. So that's y squared. And over here, look at the x spaces. Negative 1 and 2, add those two together, and we get 1. So a single x here. And then y to the third. Minus 5 times, and over here, those cancel, the y's cancel, leaving behind negative 5x squared. Now up top, we can factor out some y's, and on the bottom we can factor out some x's, but we will not get a cancellation like that, so you just leave it like that. That brings us to your turn, number 10. All right, let's take a look at the x's. Larger negative is 2, and it's the same for the y. So that means we're going to multiply by x squared, y squared over x squared, y squared. Now let's distribute in. So that gives us x to the negative 1, x squared, y squared, minus y to the negative 1, x squared, y squared, x to the negative 2 times x squared, y squared, minus x squared, y squared times y to the negative 2. Now we can use properties of exponents to combine things together. Here we have two x bases. Negative 1 plus 2 is 1, so we get x to the first power times y squared. And then over here, we've got y to the negative 1 and y squared. Add those together, we get y to the first power. So that gives us x squared y. Now here, x to the negative 2 times x squared, those cancel, leaving y squared. And over here, the y's cancel, leaving x squared. Now we should look for an opportunity to simplify. Let's see what we can factor out here. Looks like up top, both terms have 1x and 1y, so we can factor those out. And that gives us y minus x. In the bottom, we have difference of squares, so that can be factored into y plus x times y minus x. Now we have matching y minus x's, so those cancel, and our final answer is x times y over y plus x. All right, next example. All right, we want to get rid of those negative exponents. The only ones we have are a -3 on the x and a -1 on the y. So we'll turn those positive, and we will multiply by x to the third times y over x to the third times y. Now let's distribute in. Right, if I distribute x to the third y into here, x to the third and x to the negative third are going to cancel, leaving just y. And then over here, the y to the first power and y to the -1 cancel, leaving 2x to the third power. On the bottom, you can distribute in here to get x to the third y squared plus x to the third times x to the third is x to the sixth, so we get 2x to the sixth y. All right, now let's do some factoring. Out of the bottom, we can factor out an x to the third power and a y. That gives us y plus 2x to the third power. And that matches the numerator. So we got matching binomials here. Those cancel, leaving us with just 1 over x to the third times y. Your turn, number 11. All right, take a look at our negative exponents. They're both -2, so we're going to multiply by x squared, y squared. And I will distribute. All right, distributing here, x squared times x to the -2, those cancel, leaving just y squared. And here, y squared and y to the -2 cancel, leaving -4x squared. On the bottom, here we get 3x squared y to the third. And here we get 6x to the third y squared. Now we can do some factoring. Up top, perfect square, perfect square, perfect square. So we have difference of squares. So that factors into y plus 2x times y minus 2x. And then the denominator, we can pull out a 3 and x squared and y squared. All right, dividing here, that gives us y. And then dividing here gives us 2x. So there's our matching binomials. Y minus 2x over y minus 2x, those cancel. So we got y plus 2x on top, and 3 x squared y squared on the bottom. So that is it for today. These are, as the name suggests, fairly complex. They're going to require quite a bit of practice. So if at first you don't succeed, don't give up. Get some help. All right, everybody, have a great day.